hybrid L8 built for flood zones and real-world resilience. As electrification scales across diverse global markets, infrastructure instability is becoming a first-order design challenge, especially in regions facing frequent urban flooding, heavy rainfall, and unreliable road conditions. The LEPAS L8, a new plug-in hybrid SUV from Sherry Group's global EV brand, takes a different path. It prioritizes environmental resilience from the ground up. With a tested 600 millimeters weighting depth, the L8 is purpose-built to maintain full powertrain function while submerged in nearly 2 feet of water. Unlike traditional PHEVs, where high-voltage components create added risk in wet conditions, LEPAS integrates multi-layer insulation, sealed battery housings, and redundant fail-safes to prevent electrical failure. This protects the battery, reduces safety risks, and extends vehicle life in flood-prone areas. In markets like Southeast Asia, where annual monsoons are no longer disruptions but seasonal norms, the L8's capabilities speak to a broader mobility trend. Clean vehicles must now also be climate adaptive. Cars that stall or degrade in extreme weather shorten life cycle value, increase waste, and strain ownership costs. By contrast, a hybrid designed to endure high water, unpredictable terrain, and temperature extremes is a more sustainable, long-term investment for fleet operators and consumers alike. Building crash resilience into the vehicle core. The LEPAS L8 departs from conventional safety development by aligning design priorities with real-world accident patterns instead of just regulatory compliance. Rather than treating crash safety as a checklist, LEPAS applies a predictive model built around collision types, velocity ranges, and post-impact scenarios, especially in environments with less formalized emergency response systems. Critically, the underside protection was developed in response to crash modeling that highlighted the frequency of 30 to 70 kilometers per hour lower body strikes, particularly on deteriorated roads. The inclusion of rollover protection was also driven by field data, especially in rural or semi-urban areas where road conditions, vehicle height, and water hazards combine to increase rollover risk. By expanding the safety architecture beyond common NCAP simulations, LEPAS aims to support vehicle durability, protect occupants after collision events, and minimize total life cycle damage. It's a practical move for regions where access to repair infrastructure may be delayed and where vehicle downtime carries significant economic cost.